Truss and frame manufacture is the third module in this training resource, and it's looking particularly at the way trusses and frames are put together so that we can understand what is behind the delivery of some assembled timber on site. So the design software complies with ABCB protocols. Any design software that's used in buildings that have to comply with the National Construction Code, there are protocols for the development of that software, for the auditing of that software, and for the certification of that software. The trusses are accompanied by a certificate. Now this is particularly important. Often a builder, when they're tendering for the job, they will get a truss designer to give them a certificate, a design certificate for their particular work, and that's what you will see at the certification stage. That manufacturer will then take the information, which is all in software on their computers, and feed it into their fabrication plant, and it's spat out the end without pieces of paper even. There are screens that are telling these guys what they have to do. The machines that cut the timber are all numerically controlled, so that the software looks after the design and then looks after the fabrication. All of the documentation for the trusses is laid out in AS 1720 Part 5, and it includes information on the design. So what were the design assumptions? What was the design wind speed that the trusses were designed for? What additional loads were the trusses designed for? And then installation, so that the truss manufacturer will produce specific information on the installation for those trusses. Are all trusses the same? No. Some trusses are girder trusses that have higher loads, and they need to have different installation requirements for them. So that the installation requirements includes lifting and placing, bracing them, supporting them, and tying them down. Finally, there are labelling requirements in AS 1720 Part 5 that require labels to be put on trusses next to the access points that say what the trusses were designed for. This is so that future owners can be aware of what the limitations of the truss designs were. Installation documents we've already mentioned. There are some general installation documents, but each job will have some installation guidelines produced for it which outline what the tie downs and supporting requirements for those particular trusses are. And often there's a checklist that the truss manufacturer will produce that guides the builder through the process of erecting those trusses, including putting the bracing up. If bracing is not done properly, then there can be significant problems in the performance of the trusses. I've mentioned girder trusses before. Girder trusses pick up the load of other trusses. So here is a girder truss highlighted in red with other trusses coming in and sitting in fairly massive boots. They transfer load into that girder truss. So that girder truss has much higher loads than the other trusses, therefore it's going to have much higher tie-down forces and it's going to require stronger connections. The installation documentation for the job should outline that. But if you're on a job and you're seeing girder trusses, look for the connection at the end of the girder truss and make sure it is in accordance with the specification. Here's what happens if we don't get the bracing right. Can you see a small problem here? Okay. Shadows are wonderful in magnifying these problems or showing these problems up. Bracing is important in the final job, but it's just as important as temporary bracing while the job is being erected. Okay, trusses often look a little bit slender. They need to have some serious temporary bracing to ensure that they don't buckle. Also, during inspections, you may be aware of some tie-downs that haven't been done properly. Just check the tie-downs, they are particularly important. The timber used in trusses must comply with an Australian standard. So in general, it's going to be marked so that it should meet the specification for the grade and the size in the truss design. Not all members will be the same grade. It may be that some trusses have MGP 12 bottom chords and MGP 10 web chords in the middle of the truss, so that the particular grades must be appropriate for the elements that are used in that truss. Prefabricated wall frames. So prefabricated wall frames may be designed and fabricated in a plant and then brought to site and simply stood up. It's a really quick way of achieving construction. So that again, in this case, it's computer designed and computer guided in its assembly, with often some marks laser printed onto the particular elements to identify what their role in the wall frame is. They are designed in accordance with AS 1684, and exactly the same compliance documentation for the method, for the design method, applies to wall frames as well. Again, with wall frames, sometimes the bracing may be on the prefabricated wall frames, other times it's erected on site, but again, in inspection, we need to make sure that the bracing is all there.